In this video, we are going to look at a way of storing information about a graph in something called adjacency matrices. So before we look at adjacency matrices, we're going to review how we use dictionaries in Python to help us represent graphs. And we're going to show how matrices can do the same thing. They can also be used to represent graphs. And then we'll show how to generate an adjacency matrix from a given graph. All right, so let's look at the following graph. So we have, a bunch of vertices A through G and some edges that show relationships between them. So in the coding assignments that you've done so far, here's the way we've represented the graph. We've done it with a dictionary, and we've done it something like this. And so what the keys are the vertices themselves, and then the values for each key are the vertices that they're adjacent to. So for instance, if we look at that middle one with C colon the list B, D, E, that tells us that C is adjacent to B, D, and E, and no others. And if you look at the graph, certainly C has an edge between B, D, and E, and doesn't have an edge with any other vertices. So this method has some nice strengths, which is the reason we use it in Python. First of all, it encodes all the important information that we need about the graph, what the vertices are, and what the adjacency relationships are. And it also allows us to completely reconstruct the graph visually if we're given the proper dictionary. And then finally, it is an efficient use of storage space. That's not obvious here, but it certainly is compared to other ways that we can represent graphs. So we're going to look at another standard way of looking at representing graphs, and that's in matrices called adjacency matrices. So when we do this, we take our graph and we first order the vertices, so V1 through Vn, and as we've seen in other applications, we can order the vertices in any way that we want. Then what we're going to do is, if we have n vertices, we're going to make an n by n matrix, meaning we have n rows and n columns, and we're going to fill them with either zeros, each entry with a 0 or a 1. So if we look at a certain row, say row I, and a certain column, say column J, what we're going to do is, if the vertex or the edge or the pair Vi Vj is an edge, we're going to put in a 1. If the pair Vi Vj is not an edge, we're going to put in a 0. So let's look at our original example. Here's the graph that we had, and we're going to see how to make an adjacency matrix. So we're going to order the vertices in any way we want. I'm going to start off being boring, just do A, B, C, D, E, F, G. I'll just do it in alphabetical order. We're going to do it again later in not alphabetical order just to see how that goes. We don't have to put it in alphabetical order. So, and to keep track of things, we're going to set up a table where the rows are represented by our vertices and our columns are as well. So here's how it looks. If you look down the left, that's the row A, B, C, D, E, F, G. And if you look up top, you'll see the columns A, B, C, D, E, F, G. And we're going to fill in the entries in the matrix with either 1s or 0s. So the first thing to notice is if we look at A and A, there is no edge between A and itself. And actually, there's no edge between B and B, or between any vertex and itself. So all the entries down the upper left to lower right diagonal, just going to be 0. So pretty boring. Now, if we look at who's adjacent to A, B shares an edge with A, and so does D, so we put 1s in those spaces. But C, E, F, and G do not have any edges with A, so those are going to have 0s. We'll do the same with B. Notice that B is adjacent to A and C, so we're going to put 1s in those places, but it's not adjacent to anything else, so we're going to put 0s in all the other places. We do the same thing with C, and with D, and with E, and with F, and with G, and that gives us our adjacency matrices, or adjacency matrix, excuse me. We're just going to remove the letters from the top row and the left column, and that gives us the following matrix. And if we wanted to, we could take that matrix and bring it back and give us our graph back, just with that information. All right, so one thing I want you to notice is there's a certain symmetrical property to this matrix. If we look at the third row, we got 0, 1, 0, 1, 1, 0, 0. And if we look at the third column, and read from the top to bottom, we have 0, 1, 0, 1, 1, 0, 0 as well. So each row and column, if you have the ith row and the ith column, they're going to look identical if you read them in order, and that tells us that the adjacency matrix is what we call symmetric. So what that means is if we have a matrix A and Aij is the entry in row I and column J, if that's our adjacency matrix, then if we look at Aij, so the entry in row I and column J, that gives us the same value as we get in row J and column I. And as I mentioned before, that tells us that A is a symmetric matrix. Now I want to look back at our original example and show you there's not just one way to make the adjacency matrix. So back in the old days being like, what, a couple minutes ago, we ordered the vertices in alphabetical order. Now I'm going to order them C, D, F, A, G, B, E, and set up the table again, right? Except this time with a different ordering. We'll set up the, we'll look at the adjacencies in each one. Oh, excuse me. So for C, that is adjacent to D, B, and E. So I'm putting 1s there and 0s everywhere else. D is adjacent to C and A. Those get 1s and 0s go everywhere else. I'll do the same thing with F, the same thing with A, same with G, B, and E. And when we do that, we get the following matrix. And I don't expect you to remember what the matrix looked like before, but you won't be surprised to learn that this matrix looks a lot different than the old one. So we can have different adjacency matrices for a given graph, but each adjacency matrix itself has just one graph that goes with it. So again, it looks different than the other matrix, but it represents the same graph. All right, so now that you've looked at this, I think you're ready to look at the activities for adjacency matrices, and that's on the PDF file included with this video.